7, we have a uniform spherical shell of mass m and radius that can rotate around its vertical axis on frictionless bearings. A massless cord passes around the equator of the shell over a pulley and then attached to a small object of mass 0.6 kilograms. There's no friction. The cord does not slip on the pulley. What's the speed of the object when it's fallen 82 centimeters? And in this case, they tell us specifically to use energy conservation. So what are we dealing with? We're talking about the change in gravitational potential energy of the mass equals the kinetic energy of the mass plus the kinetic energy of the pulley plus the kinetic energy of the sphere. In this case, kinetic energy of the mass, 1/2 mv squared, kinetic energy of the pulley, 1/2 I omega squared for it, and the sphere, 1/2 I omega squared for it. Two omegas would not necessarily be equal to each other because of the different radii, nor are the i's going to be the same as well. Playing in our numbers, mass is falling 82 centimeters, so that 60 or 0.6 kilogram, or that equals the kinetic energy, 0.6 kilograms there, plus 1/2 times I, and they give us the rotational inertia of the pulley, 3 times 10 to the minus 3 times omega squared, plus 1/2 times I. For a spherical shell, it's 2/3 mr squared times omega squared. You can solve a lot of that. I'm going to put it down here. But there's one substitution I'm going to make. Since we're looking for velocity and not omega, I'm going to replace omega with v over r, where in this case the radius of the pulley 0.05 and the radius of the sphere 0.085. That's 8.5 centimeters. Multiplying those all out, it becomes much simpler. We end up with this. The total energy change in gravitational is 4.83 joules. Over here, doing each of the three terms, color coding it, this is the final kinetic energy of the mass, the final for the other piece, and then this one for the sphere, this is the pulley. Adding it together, we get that. Now it's just a matter of rearranging it and solving for v. You'll find the final velocity of the falling mass is 1.42 meters per second. Good luck!